So here we're going to look at the standard normal distribution and how it is calculated using the empirical rule. So I've got the sketch there of my normal distribution bell curve. But first, before we fill that in, we're going to look a little bit more in detail at what the standard normal distribution entails. So normal distribution, as is the standard normal distribution, the data is symmetrical, where the mean and the median and the mode are all the same, or they're all equivalently equal to each other. And the random variable in standard normal distribution is replaced with the letter Z. So sometimes you'll transfer from the normal distribution and then standardize it, and then your random variable will become Z. And it's normally distributed 0, 1. That's the standard setup for the standard normal. So the mean is 0 and the variance and the standard deviation are all 1. So with the empirical rule, if we just fill that in on this bell curve here, the distances from the mean are still the same as in all the normal distributions, but the values along here will take on certain values. So the mean is 0, then each standard deviation is increased by 1 or subtracted by 1 depending on which direction you're going. So going to the right is 1, 2, 3, and here is -1, -2, -3. It kind of helps us to understand what's going on to try and get our values for our probabilities, as we will do with these in a moment. So now let's fill in our values here. So the mean is at the centre, so that's the 50% either side, but one standard deviation across is 34.1%. So if I draw a line here, that will be 34.1% of my probabilities underneath the curve, and likewise for this side as well. So that is also 34.1, and that's percent. Now, two standard deviations across is 47.7% in total from the mean out to the two standard deviations. So the area under this bit in this segment will be 47.7 minus 34.1, which is 13.6. And likewise for here with -2 standard deviations. And the last bit will just be the difference between those, which is 2.1. So that will be the area under the curve in this bit. That's 2.1%. and 2.1%. Okay, so with that in mind, now let's have a go at calculating these four probabilities. So we want probability that our standard normal distribution variable Z is between 0 and 3. So using the empirical rule, all we have to do now is add up these segments, and that will give us our probability. So we've got 34.1 plus 13.6 plus 2.1. So adding those up, we've got 47.7, 49.8. So that's equivalent to 49.8% or 0.498. That's our approximations here. You can get more decimal places if you're using your calculator, and a little bit more accuracy as well. So now we've got -1 to 2. That Z is in between that particular value there. So now let's add up the values under the curve. So -1 to 2. So we want this one, this one, this one. So we've got 34.1, 34.1, 13.6. So 2 times 34.1 plus 13.6. So that's 68.2. And 13.6, that's 81.8. And that's percent. So that's 0.818 and so on. Same with that one, let's put 3 dots. Next one, -3 to 3. So you can see that will cover most of the probability that's available on this graph. So -3 to 3 would be equivalent to 0 to 3 and 0 to -3 doubled. So if you double that, you should get that by the law of the symmetry. So we've already done 0 to 3. So therefore -3 to 3, that would just be double this. So that's 2 times 49.8, which would be 99.6% approximately, which is 0.996. So that would be that one. And then the last one, 1 to 3. So that would be the area with this segment and this segment. So that is 13.6 plus 2.1, which equals 15.7%, which is 0.157 approximately, as is that one. And that's how would you calculate standard normal distribution probabilities using the empirical rule. Okay.